Alright, this was a video that I had in mind initially that was going to be fairly straightforward, and I realized after sort of putting it together that it was not going to be as straightforward as I had hoped, because we have different formulas for variance, different variances essentially, and depending on how or what you're doing and how you're looking at it. So what I'm going to do is I'm going to actually have variance just split into 3 videos rather than having all of these 3 kind of crammed into one. It's going to be a little cleaner that way. So this video here I'm going to be talking about number 1 here. This is often the formula that you see typically when if you have been on YouTube and seen other videos on variance and other instructors doing tutorials on variance. This is often how instructors like to teach it. This is the method in which they like to use. It's sort of a simple way of learning variance because it's taking variance of just simply a group of numbers. We're not getting into expected value. We're not getting into random variables. We're not getting into samples. It's just getting a variance of a group of numbers. And so it's kind of a simple way to kind of sort of ease into the idea of variance. The idea of variance is actually trying to get at, it's a measure of how spread out the data is. So if you have a group of numbers, let's go ahead and just start right off the bat here. Let's say we have a group of numbers that are, say, 1, 2, 3, and 2. That's all we have. This is not a sample of anything. It's just that's the population. That's it. We want to know how spread out. We want a measure of how spread out those data are. So you might be able to look here and just see 1, 2, 3, and 2, and you say, well, those numbers are kind of close together. They're not really varying very much. There's not a lot of variance, to use the term. And so the formula for variance is trying to get at a measure for that. So let's go ahead and look at this formula here for the variance. And it looks a little convoluted and strange and complicated, but it's really not. So don't let it sort of frighten you a little bit. Let's go ahead and take it step by step. We see here that we have the sigma notation out front here, and that is simply just the notation that tells us to add. And what are we supposed to add? Well, we're supposed to be adding this thing in the parentheses, which is a difference. We've got a difference between all the xi's, which are simply just all the values in our data here, and we're subtracting mu, which is simply just the average, from each individual value, and then squaring it, and then dividing by n, which is just essentially going to be averaging that squared difference. So if we just take it step by step, let's go ahead and just write this out and figure out what it's saying. All these xi's. So we can look at, say, the number 1 here to be x1. We could look at this number 2 to be x2, and so forth. Okay, so let's go ahead and just write out what this looks like. So since we have 4 numbers in our data, we're going to have essentially 4 terms to be adding, 4 summands that we're going to be sort of adding up. And so the skeletal piece is would look like this. We have the 4 differences, each one squared. Okay, and this I here is simply just referring to the I over here, which says to add each individual xi from 1, right, to n, and n is 4 because we have 4 numbers in our group. So again, this being the mean or the average of the numbers, let's go ahead and get that first because that's going to help out. So mu, that's the Greek letter, it sort of looks like a U with a sort of a long front end tail. We'll go ahead and make that calculation. And I'm assuming that taking means and calculating averages is nothing new to you. So if we take the average of this group, we would get 1 plus 2 plus 3 plus 2 divided by 4. And I think you'll agree that that should be 2. Okay, so there's our 2. So we're going to go ahead and put our 2 in here into our summation, into our expanded summation. And then we know we're going to be subtracting 2 from each individual xi. So the x1 would have been this one here, right? The second one would have been the 2. The third x would have been the 3. And the fourth x would have been that last 2. Okay, it doesn't matter the order here. I mean, you could make any one whatever value you want. And again, this was all divided by 4. Okay, so if we go ahead and just grind this thing out, let's take each term separately. So we have 1 minus 2, which is minus 1, squared is 1, plus 2 minus 2 is 0, squared is 0, plus 3 minus 2 is 1, squared is 1, and we're getting a 0 on the last one. And we're getting 1/2, which is this sigma squared. That's what we call the variance of a population. That's the sort of the official way of writing it in statistics, the sigma squared. Now you might ask, well, why are we squaring something? Why is it squared? I'll explain that in a second. Now, this 1/2 right here, perhaps in of itself doesn't really mean that much. It's more of a relative term because we're perhaps comparing a variance of one thing to something else. So perhaps maybe what we could do is take a second set of numbers. I'm going to choose a second set of numbers that are going to look like this, say 0, 5, 10, and 15. Now you look at those numbers and you say, well, you know, they're quite different than these numbers. These numbers here are quite sort of spread out. They're varying more from where their average is. Whereas in this particular case, in the first group of numbers, we saw that the average was 2. And you can see the average being 2, the individual numbers are not really straying very far from that. In this particular example, we have a mean here of somewhere down in the middle here, right? And the numbers are quite a bit, or straying further from the mean. So we would expect that the variance would be somewhat larger. We'd get a larger number than 1/2. Well, let's go ahead and try it. So let's go ahead and get the mean here first on this second set of numbers. So we would have 0 plus 5 plus 10 plus 15 divided by 4. Right? Okay, so then we would have what we'd have there, 30 divided by 4, which is, well, 15 divided by 2, which is 7.5. I'll put that 7.5. So there's our mu, and since we also have 4 terms, four numbers in our group, then we would have 4 terms in our expanded summation. And 7.5 was our mean, so I'll write that here. Okay, and then each individual xi, which was, you know, here this was x1, this would be x2. Again, doesn't matter which one you choose to be what. Okay, so we would have had 0, 5, 10, and 15. Sorry for making that a little crammed there. 15 minus 7.5 squared. So in this particular case, now let's go ahead and expand this. Okay, this is divided by 4 still. We're averaging, right? This is simply just averaging all of these square differences. So we end up here with a minus 7.5 squared for the first one, right? So we would have, I believe that's 56.25. And then on the second one, 5 minus 7.5 is a minus 2.5 squared, which is a 6.25, plus 10 minus 7.5 is a positive 2.5, which is also a 6.25 squared, 6.25, plus we'll get a 56.25 there, all divided by 4. And if we go ahead and just do the numbers, we get 125 divided by 4, 31.25. Let me just do it real quick. I think that's right. 125 divided by 4. Yes, 31.25. Now, there's our variance for this group of numbers. You can see how we've got quite a big of a jump here in the variance compared to 1/2. And so the variance was quite a bit larger, as we suspected it would be. So the variance, again, is a measurement of how spread out your data is. And very often it's not really very intuitive, because we're dealing with something that's, we're dealing with a squared difference that's averaged. And remember, we talked about this was actually called sigma squared. The reason why we call it sigma squared for the variance is because the plain sigma without the squaring is what they call the standard deviation. Now, the standard deviation is something that is actually a little bit deviation, here we go, we can spell deviation. The standard deviation is something that's a little bit more intuitive to think about, because as you'll notice, sigma is essentially just the square root of the variance, correct? So the square root is essentially sort of undoing the square. So we could look at, if we go back up here to the formula for variance in number 1, we could look at the standard deviation. Since the square root of the variance is undoing the square, we could look at it as essentially the positive difference between each data value and the mean, averaged. So you can look at the standard deviation as simply the averaged distance of each data point from the mean, the average spread. And so again, it's a more intuitive concept. So you can look at this. You could look at the variance as simply the square of that. Another important thing to remember about variance is that in variance our units are also squared. So I'll put this down. Units are squared. Whereas with standard deviation, our units are in the original units. So for example, let's say that we were measuring, let's say that in this first group of numbers here, right? Let's say that those were, say, measured in inches. Well then, if we got our number for the standard deviation would also be in inches. The variance, however, would be in inches squared, which makes things, again, a little bit less intuitive to kind of contemplate. So I always like to tell students who are learning this concept for the first time and trying to sort of picture in their minds what a variance is. Again, it's a measure of the spread of the data, but the variance is sort of the average spread squared, okay? Whereas the standard deviation is a little bit more of a straightforward, essentially which is just the average spread. So it's a more of an intuitive term. I'm going to go ahead and stop here because I'm kind of going over 10 minutes. I don't like to go over 10 minutes because I run the risk of losing my audience. I'm going to, in the next videos, talk about number 2, which is a sample variance. And now we're getting into concepts of taking samples of populations. We're getting into sort of random variables and different kinds of distributions, in which case we often are going to need concepts that we're going to be using variance as a number 3, where we're getting into expected value and so forth. Numbers 2 and 3 of variance are actually getting into more of the heart of variance, whereas in number 1 it's sort of more of a simplified concept of variance that often instructors like to use just to introduce it for the first time. Hope to see you there. Have fun.